Hi, I'm going to explain about generics in Java. Here we'll first look at types in Java, data types in Java, then how data types can restrict our code and why restrictions are important. Then we can look into how we can go beyond restrictions and write Java code that is not limited by types. And then we look into how generics can restrict types in Java, data types in Java, in a way that is very meaningful to us. So here, to start, we'll first look into four words. The words would be, first we have heard of a word called statically typed and dynamically typed. Then another two words we know is strongly typed and weakly typed. So when it comes to these four words, they have definitions, but there is a gray area as well. For example, statically typed means a language where the compiler knows the type of every variable. So you don't have to wait until the runtime to know the data type of any variable. In dynamically typed, it implies the compiler might not know all the data types, but when you are running the code, you can infer the data type from the runtime. So one way of making a language statically typed is always typing the data type before a variable. But there are gray areas in these words as well. Then we have two words called strongly typed and weakly typed. In strongly typed, the idea is you should not be able to get from one data type and put it into another. For example, you should not be able to put a string into an integer. In weakly typed, you should be able to do that, and it might mess up the programs. But then there are cases where, like, putting an integer into a long or a float into an integer, these things. So we have come up with different ways of defining these words to handle these gray areas. So my advice to you would be, learn what these things are, but then understand that none of these words actually reflect the real programming languages in full. For example, even words like object oriented programming, that is not very meaningful when it comes to real programming languages. Anyway, first we'll think of a very naive Java application. So what I'm going to implement is, I'm just going to think about a class called kid. So kid. So this kid has two functions. So let's call this a very nerdy kid. So he or she goes to school and then goes to university. That's all he or she does. Then we might need to, so in this Java class, one of our requirements is we should be able to set school. That means we should be able to give some information about where the kid went to school, to the class. Then other one is set unit. We will have to set the information where or how the kid went to university. The other one would be print education, where we get back the information about the education of the kid. The other one would be print total, where we get out the information about the total education of the kid. So this is a very high level understanding. I didn't go to specifics about what school and university are in this kit, because I want to keep them open for the sake of the exercise we are going to do. So I'll start writing the code. First of all, I am going to create a class called kid. So the first version I'll call kid1.java. So I am going to call this class kid1. So in this example, I'll first think of this as the school and the university are the number of years the kid spent there. So I'll go with int university and school are going to be the variables of this class. And then I'm going to have set school function where I give an int number of years for uni. Let's say I'll call it uni. What's going to happen is I'm going to assign it to the instant object variable like this. So I'm using this keyword here to handle the issue of have this parameter being named as uni and the internal variable of the kid object being uni. And then same for the university. So this one would be university and this one school. School. This dot school. So I'm going to assign it like this. Then I need, so these are numbers, integers. Then I would want public. I'm going to have another function to print the whole education thing. I would say it is void print edu. What we do is we are going to print out first. I'm going to put in education edu, keep a space. Then I'm going to print school information. Then I'm going to print a space. Then I'm going to print the university. So the third line, since it's the last information that I want to print in this line, so I'm going to go with the print ln. So the console cursor will go to the next line. And then I need something to print the total number of years. Public void print total. What I am going to do is I am going to calculate the total as school plus university. So maybe I'll have this variable in the class as well. And then I will go to print it. I will go say total. Then I will print the total. So this is a very simple class. So I'll just run it and show how I should run this is I'll create a kid1 class called, let's say, kid A. So he will be kid1. He or she will be kid1. And then I am going to set the two parameters, the university and school. Let's think this is a smart kid who happens to finish school in 12 years and finish the university in 4 years. So if I go ahead and go kid A, I'm going to print education and I'm going to kid A print total. Let me try running this. So when I run it, I get that in education was 12 years and 4 years and the total was 16 years. This is a working piece of code and I don't think it's complicated at all. Now let's think of a case where these students, kids, school and university are not integers. They are supposed to be words where they went to school and where they went to university. So if I am to do that, I'll create another one called kid2 class. where these things are strings. So set uni would be a string coming in, set school would be a string coming in, print education would not be changed, but this adding business you can't do it there because you can't add like words. Strings are not things like numbers that you can add. So I'll delete that. I'll comment out that class, and this is going to be kid2.java. And if I look here, so obviously I should change the class type to kid2, and we can call him kid b if we want. So I don't have this print total functionality, but the rest of the thing. So his school would be, set school would be, uh, let's say Central College, and set university would be UOP. So I'm going to run this. So it says education was Central College and UOP. This is the space. So this also makes sense. Now I wrote kid1 class for integers and kid2 class for strings. But now let's say I don't want to do both these things. So I'm going to think of a way that I can write this in a generalized form such that I don't have to write this part twice. For that, I'll call class kid3. So kid3 is not going to be restricted by whether this part about school and university are strings or integers. For that, so what is the most generalized form in a class? That would be the data type is object. So I'm going to call it object. So university and school are objects for this kid. Then I'm going to have public void set school. Here I'm going to get in an object called school, and I'm going to set it. Same goes for university. Void set university. Set, I call it set uni. Then it's going to be an object called uni, and the idea is it's going to be this because uni. And then I need a function called print edu. Print edu object. I don't need anything passing it. What I would do is I would just go with this part because it works. So I don't care what the school is and the university is. And one important thing to know is in Java, whatever the object is, you can print it. So that is something very straightforward in Java that you should know, that you should be able to print anything in Java. So here I would write a main method to handle this. I would first create a Kid3 type called KC, the C kid, new Kid3. So I would go for K3.set uni, and I'll go for PDN. But I can't pass in a string because they are expecting an object. I would have to typecast it object. Then so this is KC. KC.set school would be an object of let's say school X, something like this. Then I would do kc.print value. So this should work. So this is kid3. So it works. So education, it prints school X and PD. And then I would go for another kid. This is going to be kid D, same type. But here I'm going to send in a number like 1. So in university, let's say he or she did a 3-year degree, and in school they spent around, they did 2 attempts for adults, so 14 years. So if I run this, I'm going to get this for the second one, KD. So let's say KD. So I made a mistake there. So this is the KD. So I'll compile it again. So you see, the first one, school and university are PDN and school X. Second ones, same things are 3 and 14. So you see those things getting printed. It works, but the idea was you had to always give in them as objects. This is good, but let's say we want to take out these variables for some reason. For example, instead of printing education from within the class, what we wanted to print them here. So system. So let's say we are going to take it out from the KC. So his or her variables are strings. They are as objects, but they are strings. So I would have to write string school equals. I can write KC dot school, but I will have to cast it to string before using. Then I can go for system.out.string. I can print this. Maybe I'll print something before that. After that, just to be sure that I'm printing it. So for example, I'll print something like this. So if you look at this, I can get it out and print it. But here I have to remember the data type and cast it here. When I'm sending in also, I have to cast it. So I do the same thing for the second person with this string thing. So that's going to be KD, right? I'll say school 2. Can I do it? No, I can't do it because the second one's KD is school is an integer. So I'll have to cast it to int. Now it works. So the problem is, even though this works and you have absolute freedom to do anything here, for example, even for the same person, you can give an int as the school and a string as the university and do anything, but you have to remember everything. And the other issue is, so when you have to remember everything, it's messy code. So why even bother typecasting everything? So the so you have absolute restriction here, just one type, but the issue is you have to write the same code over and over. You have absolute freedom here using object type, but the problem is you have to always remember the data type and write it in your code. So the obvious question is there a middle ground where both these things are at least somewhat fulfilled? There should be some sort of restriction to stop us from having to write the data type always, but you should be able to write the functions once and use it for any data type. That is where the generics come. So now I'll talk about Kid4 type class. Kid4. Now this kid is going to have the same 3 functions. They would be set school, set uni, and print edu. Here, but I'm going to say that it is going to only work on a particular type. I'm not going to say what the type is, but I'm going to call it as T, and then I'm going to put it everywhere. For example, I'm going to say if the kid has variables school and uni which are from this type T, and the functions work with that type T as well. So this is like I am giving a blueprint for these functions. What it can take any data type, but there is a restriction saying it should be T always. So now where am I going to define this T? For example, now let me think about creating this KC kid. I'm going to call him kid. So now he is of Kid4 type, and I'll call him KX. So new Kid4. But when I'm initializing this kid, I'm going to say this type T should be integer. And I'm going to write it here as well to say this Kid4 type this is a kid of Kid4 type, but this T should be integer for KX kid. So what I'm going to do is let me do KX dot set school. I'll say central college without typecasting anything, and I'll say set unit to PD without typecasting anything, and then I'll go for KX dot print edu. Now if I run this code, let me try running it. Oh, I'm sorry. So I was going with integer here, so I can't say this. So I should say sentence. This is a number of years, and this is a number of years. So it runs. It works. And the most important thing is like, so if you see what happened here. So if I just try to pass something else here, it's going to give an error. The error comes from me saying this kid4 should always behave with this type T, and here I say that type T is integer. So you have to always give integers here. So I'm going with something like this. Then I want to have another kid X, let's say kid4 with strings ky kid4. So for him or her, I would go with set school, central college, and ky dot set unit. I'll say parent, and then ky dot print edu. Let me try running it. You see, I get the results here. So the idea is you can write the class in generics with type T here, and then when you are initializing the class, when you're creating objects out of the class, you can give a data type for this generic, and then it's same as writing the code twice, but instead of writing it twice, you write it once and do it this way. Here you don't have as much as freedom as doing it with this complete freedom in object data type, but here you don't have to remember everything and pass things or get, even if you're taking something out like ky dot school, you don't have to cast it back to strings. You can just take it like this. So that makes your life easier. So restrictions are not always bad in programming. When you have restrictions, there is a little bit it's a kind of a safety net from making mistakes, but you can't do everything here. So if you want to do everything, you have to go for complete freedom, but then you should be careful as well. So that's as same as it's in life. Now if you look at this, yeah, now we have done a lot of things, but if we look at the first one, what we did with int, here there was a function to print the total. So you can't do it here because there is no way of adding strings. Here you can't add strings or add objects because you don't know whether the object can be a string. So here also it won't work. Here you can't do it because you are using strings and integers as this type T. But what if I want to do this print total thing? Then what I would want to do is I would have to put a restriction on this T saying this T can only be a number. For that, I am going to go for Kid5 type class. So I am going to call it Kid5.java. And here, when I am coding the class, I am going to say key extends number. So what number is? It's a class. It's an abstract class, which is the parent class of all the number types. Things like integers, floats, doubles, and everything is a number. All of them are extended from number. So when I say t extends number, whatever this t can become, it should be a number. So the word number here is used in a Java abstract class name. It's not the English word of number. Anyway, now I'm going to say t. The internal variables are school and university, and then I'm going to have functions to set school and these things. So they are going to be set school is going to be this. This is also this, and this is also this. So all these things are clear because they are written in generics. I can just copy the code and it's all written in the type T. But and for these things, T being restricted to only the classes that are extended out of number doesn't also add a difference, because printing is a possibility for any class type, and these things are just assignment. So, but now we're going to have a new thing here, which is print total. So here, what did we do? In the print total, we did this. So now, if I'm going to write a piece of code saying kid5 is going to be of type integer. Let's say KC, kid5 integer. I can KC dot set school. I'm going to say he or she spent 10 years in school, and KC dot set university is going to be 5 years. They did medicine. Okay, it's 5 or 6. They were very smart, finished school in 10, but then they went to the medical faculty and spent a large number of years there. Then KC dot print education and KC dot print total. So here I am going to say we are going to have a Kid5 type of class where t is an integer. So this works because you have this extends number thing. So if I try to create a KC saying K double Z with this T type being a string, will it be possible? No, this is impossible. This is possible. Why is that? That's because we put this restriction saying it's a number. So this code, so intuitively this code should run, but there is a small issue here on how Java handles these things. For that, I have to modify this line of code from this line of code. So this is the obvious thing that should work. So when you are trying to understand the concepts, think about this line and understand it. But if you want to run it, I have to go to this line. So it runs. So why? But I'm going to comment out this line because I just want to talk about the concept here. Here, why it's possible to add these numbers are because I am going to say it's a number. So anyway, now if I have this part saying KWZ is a string, string on this t variable. So if I try to run it, what's going to happen is it's going to say I can't have a string where t extends number. So we have a restriction, a clear restriction here. So that's how the code works. Let's ignore this line of code for the time being because that's not the purpose of this session. We are not going to explain about syntax of Java. That's not the idea. We are going to learn what generics are. So the idea, to summarize, we can write functionality by just writing for a single data type, and then we'll have to repeat the same code for different data types. Then we can go for complete freedom with object data type, but then in your main method or else the part of the code that is using the classes you write with the object type, you'll have to always cast things when they are going in and when they are coming out. And the other idea is to go with generics. So generics has solution to that, but generics might be a little bit too open-ended to do certain operations. So in order to do those operations, we can put an restriction on the generics by extends keyword. So extends means this is an abstract class, and this is this should be a class coming out of this abstract class, and number is a abstract class in Java. So thank you for listening, and bye. I'll upload the code in a GitHub repo and link it here.